Hey, what's going on YouTube? And today we're starting part two of the Python programming massive open online course by the University of Helsinki. We finished part one. In the previous video, we wrapped up the remaining exercises related to part one. So we're going to start with part two in this video. So these are the sections that we expect to go over. One on programming terminology, another one on conditionals, another one on combining conditions, and we're going to start loops in part two. These are the list of exercises that we expect to cover. And I think there's about 20-something, 23 exercises in here, give or take. So we got a little bit of work to do, but which is around the same amount of exercises we did for part one, so that's not really too big of a deal. Before we get started, I wanted to talk about this the GitHub repo that I created to accompany the YouTube series. So I have some information, put it up here. Just have to edit this just a little bit. And I started uploading the solutions to part one. I'm going to finish uploading the remaining, I think, 15 exercises, solutions. But I have part one, which was just the printing of the emoji, all the way up to part 8. And then after this, I'm going to upload the remaining exercises. But the repository is up. The link will be in the description. And I've also went and added back to the description of the previous video. So for anybody watching that video, you should also see the link to the repository. Please come take a look. You can add it to your watch list for any updates. But if you can give it a star, I will really, really appreciate that. It means a lot. I know that a lot of people are actually interested in the content and are following along. But yeah, this is the official repository that I created that goes along with the videos and the courses and the course material that we're going to be learning and covering in the videos. So make sure you give it a look. So let's start with part two. So in this section, programming terminology, the learning objectives are that you will be familiar with some essential terminology in programming. You will note the difference between a statement and an expression, and you will be able to find out the data type of an evaluated expression, and you will have learned to use debugging methods to find mistakes in your code. So it says, in the first part of this course, we didn't pay much attention to terminology, which is very true. That's why I kept having a little bit of tangents and sidebars discussing some of the idioms and paradigms and whatnot, and some of the terminology that we got to see. Again, if you go back to the About This Course page, you will see down here that they have these accompanying lectures, which I'm assuming, I haven't watched all of them, I'm assuming that they'll be talking significantly about some of the terms that you learn, because these lecture recordings are more university tailored. They have slides and the instructor is going through those slides. So they might be a little bit more comprehensive than just reading the material here and the course material and just doing the exercises. So if you want to learn a little bit more, I'm coming from a background that I'm already exposed to Python. I'm already exposed to programming. I have a bachelor's in computer science. So some of the terminology and terms that are being used and some of the conventions that are being covered in the course material, I already have some exposure to. But I try to explain some of that stuff as we come across it. All right, so let's continue. Statement. A statement is a part of the program which executes something. It often, but not always, refers to a single command. For example, print hi is a statement which prints out a line of text. Likewise, number equals 2 is a statement which assigns a value to a variable. A statement can also be more complicated. It can, for instance, contain other statements. The following statement spans 3 lines. And this is the conditional block, right? We have if name equals Anna, then we print this statement, and then we print this statement. So a statement is just a line of code. So this is what you should think of when you hear somebody say, write a statement in programming. It just means write a line of code. And again, statements can span multiple lines. So if you have an if block like this, then this entire thing from the head of the conditional to the last line inside the conditional block is called a statement. In the above case, there are 2 statements, a print statement and an assignment statement within a conditional statement. A block A block, and I've used this term before, a block is a group of consecutive statements that are at the same level in the structure of the program. For example, the block of a conditional statement contains those statements which are executed only if the condition is true. So this is a code block because these are nested within the conditional statement. So here we have a condition that checks if age is greater than 17, then do this. So print you are of age, then increment age by 1, and then print you are now 1 year older, and then the block ends. Now, in Python, they don't use curly braces to signify the, where the code block starts and ends. If you have some programming experience, for example, let me just go down here to an exercise block like this. Like in JavaScript, for example, say if A is greater than B, then, do this. So the curly braces signify the start and closing of a conditional block. But in Python, we use the semicolon or the colon to signify that this is where the conditional block starts. So I think that's, sometimes makes it a little bit hard for especially new programmers who are learning Python as their first language to be able to differentiate coding blocks, but this is how they do it in Python. And then here we print, this here belongs to another block. In Python, blocks are expressed by indenting all code in the block by the same amount of white space. The main block of a Python program must always be at the leftmost edge of the file without indentation. So this program will not work because it's not written at the leftmost edge of the file because Python thinks or interprets as this belonging to a code block, but it's not. It exists on its own. It's just a print statement. So print hello world, print this program is not very good. But this will not execute because it needs to be at the leftmost edge of the file. Expressions. An expression is a bit of code that results in a determined data type. When the program is executed, the expression is evaluated so that it has a value that can then be used in the program. Here are a few examples of expressions. So 2 plus 4 plus 3 is 9. And expressions is also terminology used in mathematics. We know that this is an integer type, and Python will also interpret it as integer. Here we have two strings being concatenated. So ABC plus DE creates ABCDE. This is a string type, and the corresponding Python data type is string, which is written as this, as str. Here we have 11 divided by 2, which returns 5.5. This is a floating point number, or the float type in Python. And here we have 2 times 5 is greater than 9. It evaluates to true. This is a Boolean value, and bool is the corresponding Python data type. Because all expressions have a type, they can be assigned to variables. So the variable x is assigned the value of the expression 1 plus 2. So the variable x is equal to 1 plus 2, or the variable x is equal to 3. Simple expressions can be assembled together to form more complicated. So if you print x, it's going to return 3. It's not going to return 1 plus 2 because we're assigning the value, the returned value from this expression being evaluated. Simple expressions can be assembled together to form more complicated expressions, for example, with arithmetic operations. The variable y is assigned the value of the expression 3 times x plus x squared. So y is equal to, and just for context, assume that this expression exists in the same scope as this expression. So when we do y is equal to 3 times x plus x squared, it's the same thing as doing 3 times parentheses 1 plus 2 plus parentheses 1 plus 2 squared, or 3 times 3 plus 3 squared. Function. A function executes some functionality. Functions can also take one or more arguments, which are data that can be fed to and processed by the function. Arguments are sometimes also referred to as parameters. Did I say functions or arguments? Arguments are sometimes also referred to as parameters. There is a technical distinction between an argument and a parameter, but the words are often used interchangeably. For now, it should suffice to remember that both terms refer to the idea of some data passed to the function. A function is executed when it is called. That is, when the function and its arguments, if any, is mentioned in the code. The following statement calls the print function with the argument, this is an argument. Now, I'm not happy about the way this is structured. I wish they would have showed an example of a function being written here and then a function being written with an argument passed to it. But we have come across the print command. We've referred to it as a command before until we got introduced to this terminology called a function. But this is a function. And the argument that we pass is the string that we want to be printed. But yeah, this is a function, which we've referred to in the past as the print command. Another function you've already used often is the input function, which asks the user for the input. The argument of this function is the message that is shown to the user. So variable name is equal to an input, and this is the argument that we pass, basically prompting the user to give us a name. But the function input is what handles in the back end what comes into this, what the user inputs, what the values inputted. Now it automatically accepts strings. That's why in the past we've wrapped it with an integer function to convert whatever we put in here into a string. Into an integer. In this case, the function also returns a value. After the function has been executed, the section of code where it was called is replaced by the value it returns. It is another expression that has now been evaluated. The function input returns a string value containing whatever the user typed in at the prompt. The value of a function returns is often stored in a variable so that it can be used in the program later on. So yeah, so if we were to do name is equal to input, please type in your name, and then we print name, then what's printed will be what is returned from when the user inputs their name or whatever string value. Again, I would have loved if they showed that here before we got to data types, but we'll dive a little bit deeper when we start doing the exercises that correspond to this part. All right, data type. Data type refers to the characteristics of any value present in the program. In the following bit of code, the data type of the variable name is string or str. And the data type of the variable result is integer or int. So name refers to a string, Anna, and result is the integer 100. You can use the function type to find out the data type of any expression. An example of its use. So here print type, and we pass Anna. So the type function evaluates what data type the argument that you pass to it is. In this instance, you're gonna pass the string Anna, and type is going to return the class string. Same thing when we pass an integer, it's gonna return an integer. So the type function is what we can use to find out what a certain data type is. So we can even pass here an expression that evaluates to a Boolean, like A is greater than B if we have A and B, or 5 is greater than 6, it's going to return false, and it's going to return class Boolean or bool. Syntax. Similarly to natural languages, the syntax of a programming language determines how the code of a program should be written. Each programming language has its own specific syntax. Very true. Like I demonstrated earlier, if conditionals in JavaScript, for example, or Java don't use colons, they use curly braces to mark the start of the block and the end of a block. But in Python, we use colons and white space to signify that this is a coding block that belongs to this if statement. The syntax of Python specifies, among other things, that the first line of an if statement should end in a colon character, which is what I just talked about, and the block of the statement should be indented, so like this. If the syntactic rules of the programming language are not followed, there will be an error. So if name equals a string Anna, and we don't put a colon here, but we do indent and say print hi, we're gonna get this, file test.py line 1, if name equals Anna, syntax error, invalid syntax, because we're missing that colon here. Okay, debugging. Again, I kind of feel like they're breezing past through this. I think the exercises should come immediately after we cover just a section, just to get that stamped into your brain in the time being. But the exercises come way later, which I don't know. I mean, it's okay, but we move on. All right, debugging. If the syntax of the program is correct, but the program still doesn't function as intended, there is a bug in the program. So if you ever heard the term bug related to programming, this is what it means. It's just an error or a problem that is preventing our code from being executed from start to finish. Bugs manifest in different ways. Some bugs can cause an error during execution. For example, the following program. Variable x is equal to 10, variable y is equal to 0, result equals x divided by y. Print, we're using f strings. X divided by y is result. And then this is going to cause an error. So this is an execution error, zero division error. Integer division or modulo by 0 on line 3. We can't divide by 0 because, we just can't in mathematics. The problem here is mathematical in nature. Division by 0 is not allowed, and this halts the execution of the program. Errors during execution are usually rather easy to fix because the Python will tell us where the error is and what the error specifically is. So here we have a division by 0 error. So Python is telling us that. Because again, errors during execution are usually rather easy to fix because the error message states the line of code causing the error. And again, sometimes it will tell you what the error actually is. Of course, the actual reason for the bug might be somewhere quite different than the line of code causing the error. And we'll go through this because sometimes you might write a function that does something and then you call that function later on. So it can point to, so the body of the function could contain the error, but we don't know until that function is called. And if that function is called later, then it might say, oh, error when you're running this function, and then you have to go and find where that function is. Sometimes a bug in the program is revealed because the result the code produces is wrong. And this is why earlier in the previous videos when we were doing our exercises, I would manually input the different test cases that are given in the instructions to see if we get the exact same results. So this is another one of those errors. So the program could run from start to finish and you have no execution errors, but it could be a problem in the expected output. Discovering and locating this type of bug can be challenging, especially when you have really, really long and extensive programs. In the programming exercises on this course, the tests are usually intended to reveal bugs of this type. Before a bug can be fixed, its cause must first be located. Programming jargon refers to discovering the causes of bugs as debugging. It is an extremely important skill in any programmer's toolbox. Again, and this is why in the very first video, or probably the second video that I made related to the course, I said that in the dawn of AI and vibe coding and basically programming with either relying too much on AI or relying completely on AI, while not understanding the code being written and not knowing how to program in the language that the code is being written in, can cause problems in the future in this step when it comes to debugging, when it comes to finding where errors are and fixing those errors, or reading the code and being able to digest what the AI produced to an extent which will allow you to debug when inevitably errors occur. So this is why I iterated this in the first few videos. It's a very important toolbox, especially now in the dawn of programming, or in the age of programming relying heavily on AI or overwhelmingly on AI or completely on AI. Being able to debug is such a useful skill. Professional programmers often spend more time debugging than writing fresh code, especially when you just joined a new project, like you're new on the team or you're new at the job, at your job, and they're getting you up to speed, and you gotta learn and figure out what the written code is doing, and you might see some errors, or there might be errors that you're already brought in and told that you have to fix. So debugging is a very, very, very useful skill to have. A simple yet effective way of debugging a program is adding debugging print statements to your code. Verifying the results of your code with print commands gives a quick confirmation the code does what you want it to do. The following is an attempt to solve one of the exercises from the previous section. So this is the program that was calculating the hourly wage. So we have a variable here called hourly wage, which takes in a user inputted value of the hourly wage converted to a float data type, or just a number with decimals. Then we store what the number of hours they worked and what day of the week it was. And remember in the exercise, if the day of the week was Sunday, then the wage doubles. So we calculate what the hourly wage was here, and then we print it out. So the program doesn't work quite right. Executing the tests prints out the following. So we get an error here, Python editor test with input 20, 20.06, and Sunday, correct wage 240 is not found in the output daily wages 120. So there's a problem here in how the wage is calculated. Again, we've already calculated the daily wages, but when we do this, we're not assigning the value returned here back to daily wages. So it would have to be daily wages times equals 2, or daily wages is equal to daily wages times 2, and then we print it out. When debugging the exercises on this course, the first step is often checking how the program behaves with the input specified in the test that failed. Indeed, the result isn't what was expected, so daily wages 120 euros. Debugging usually means running the program multiple times. It can come in handy to temporarily hard code the problematic input instead of asking the user for input each time. In this case, hard coding could look like this. So hourly wage is 20, hours 6, day of the week is Sunday, and here we say daily wages is equal to hourly wage times 2, and if day is equal to Sunday, double daily wages and then print daily wages. The next step could be adding debugging print statements. The problematic part of the code is in the section dealing with Sundays, as we noticed earlier. So let's add print commands before and after the line that should double the daily wages on Sunday. So daily wages is equal to hourly wage times hours. If day is equal to Sunday, then print wages before. It's going to print the daily wages. Then we're going to double daily wages incorrectly, but we're going to double it. And then we're going to print wages after doubling. And then we're going to finally print what the daily wage is in euros. So running the code now reveals nothing. The debug and print statements aren't printed at all. It seems that the contents of the if block are never executed. So there must be a problem with the conditional statement. Let's try printing out the value of the Boolean expression. Print condition, so daily wages, print condition, day is equal to Sunday, if day is equal to Sunday, blah, 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 blah. So when we print, condition is false. Oh, wow, this was, okay, I got ahead of myself. So there is a discrepancy here. So day is written with a capital case, but when we're doing the conditional here, we check day with Sunday written in lowercase. So that's also another error that even I didn't pick up. So that's why the if statement wasn't being executed correctly, because day isn't being matched by case. And this is one of those things I mentioned in a few videos ago, where sometimes what you will want to do when you're taking an input is a string input is to convert it to a completely lowercase string so that issues like this don't arise. So sort of like just handle all case scenarios. So if somebody enters an input with weird, wonky casing, whether it's uppercase with the rest of the word being lowercase or uppercase letters sprinkled throughout the entire word, just make everything lowercase and then do the conditional statement, or then send that value into a function as an argument. So yeah, so this isn't being executed because Sunday is written with an uppercase letter before, when it was supposed to be written with an uppercase letter when we were saving the value of the day of the week. Okay. So that was the first error. So this program must lie within the condition of the if statement. As in so many situations in programming, the case of letters matters also in comparisons. Notice how the Sunday in the Boolean expression has not been capitalized, but in the input, it was. Let's fix this in both the print command and the if statement. So here in the print, we put this to uppercase, and in the conditional, we also put this up to uppercase. And so now this if statement will run. So running this prints out the following. Condition true, wages before 120, wages after doubling 120, and then daily wages 120 euros. So now we get to go ahead and solve the issue over here, which is what I'm sure they'll talk about down here. It seems the value stored in daily wages is correct at first. Hourly wage is equal to 20, and hours is equal to 6, and 20 times 6 is 120. The command, which is supposed to double the figure, doesn't do so. However, so there must be a problem with the command. And indeed, the command, daily wages times 2, does double the value, but it doesn't store the new value anywhere. Let's change it so it also stores the new value. Like what I mentioned earlier, you can do daily wages times equals 2, or daily wages is equal to daily wages times 2. Running the program again reveals that the printout at the end is now also correct. So the condition is true, wages before is 120, wages after doubling is now 240, and daily wages printed is now 240 euros. When the program has been fixed, remember to remove all debug and print statements and other code added for debugging purposes. This example was quite simple, and in such a short program, one could probably figure out the bugs just by reading the code carefully. Exactly. We kind of got ahead of ourselves. That's why you got to read the code carefully. However, using the debug and print statements is often a quick way to get a feeling for where the problem might lie. Print statements can be used to figure out which parts of the program seem to work correctly, so bug tracking efforts can be concentrated on the sections of code which are most likely culprits. Debug and print statements are only one tool for debugging programs. We will come back to this subject later on during this course. You should now get into the habit of using debug and print statements to look for mistakes in your code. Programming professionals cannot get by without using them, so it is a very useful tool for beginners as well. Now, if you're wondering why it's encouraging us to remove debug and print statements and other code added for debugging purposes, well, it's pretty simple. Say, for example, we're writing a program that's going to run on the browser, and we litter our code with all these print debugging statements everywhere. Now, what happens, for example, if you're building a program that handles user registration? So people being able to sign up, sign in, update their account details, and whatnot, things of that nature. And let's say when you're writing this program or you're building this web app, and you encounter errors creating or implementing one of these functionalities. Let's say, for example, the user registration process, right, being able to sign up is not working. So you go into your code and you're debugging and you write all these print statements to help you figure out what the errors are. And you fix the problem. Now users can go to your program that runs on the web. They can go there, they can give their name, give their email and their password, and they can register. But if I'm somebody who's malicious, aka a hacker, all I have to do on the browser is right-click and go to inspect. Now, whenever your app is running, it's going to print out some of those print statements in here in the web embedded console. And so if you, for example, have a print statement that writes what the user inputs as their email and also prints out what the user writes as their password when they log in, then I can use that, right? I can see, oh, wait, this is actually telling me these details. And if I'm malicious and I'm good enough at hacking where I can, for example, get keyboard input or be able to monitor somebody's screen and see what they're printing, then I can just wait until somebody logs in and prints that statement. So yeah, I mean, that's just one way to you can think about that. Why it's important to remove these debug and print statements and also be very cautious about what kind of values that you print out to the console. Or that you use in print statements so that you don't end up printing something valuable, like a valuable piece of information, like a user password, and then and just leaving that in there until somebody who's malicious enough and curious enough starts poking around and sees that your web app is printing out some of these valuable, sensitive information. Or you could be printing out API keys, right? You can say, hey, why is my program not reaching out to the API? Let me print out if the API key is correct. And you print it out, or you do like a conditional that compares whatever's being printed out and whatever you set as the API key, and then you forgot to change it, and now somebody comes in there and is running your program and sees, wait a minute, this guy's printing out valuable API keys. Now I can go and use those on my own projects or some other malicious intent and leave you hung and dry out to cover the costs, because using APIs is very expensive. Okay, so here we have the 3 exercises that go along with this section. So what I'm going to do is I'm going to stop the video here, and then in the next video we're going to solve these exercises. So stay tuned for that. I hope I covered some good details in this. If you have any questions, if you're curious about anything, just leave it in the comments below, and I'll be sure to get to it and respond as thoroughly as I can. Again, the repository to the GitHub that where my solutions will be posted is in the description, so click on that, go through it. Please give it a star if you can. I truly, truly, truly appreciate it. So I'll see you in the next video where we go through these 3 exercises.